Guys, confirm audio and video. Yeah, confirm audio and video so we could start the session. People who are live, you guys comment hi, hello, I'll get to know you are live so we can start the session. There will be some lag between the communication because that is the property of YouTube. It delays the video by 9 to 10 seconds. People who are attending the session live comment hi, hello so I could see. Yeah, the streaming has started. Rohan, good evening. Avishkar, good evening. We'll start in a minute or so. Again, we'll be live for an hour or hour and a half. Let us see. People are still busy watching IPL. So I have collected for you, created for you questions which are at par with CAT. And I have shown you guys in the last session, the CAT has gone beyond the basic classroom booklets. So we'll start in 2 minutes. Yeah, I'm trying a new interface. Atharva, good evening. All right, let us start. Let us start. So you guys take a minute, give it a shot. Look at the kind of sequence we have. There are how many terms? 20 terms in the sequence. Can you find the sum of this sequence? First, you have to identify what kind of sequence is this. Then you have to find out general term. Then you have to find out the addition. So the first question I've selected for you has a lot of theory and concept behind it. It's a very common kind of question in all kinds of exams, all kind of exams. If this was SNAP, maybe the sum will be asked for 10 terms or 8 terms. This is CAT, they might ask you for something different. What is the ratio of 20th term by 10th term? Or what is the sum of 20 such terms? So go on, try. Find the sum of first 20 terms of the series. 1 plus 10 plus 23 plus 40 plus 61 plus 86. First, you will have to find out general term. From the general term, you have to find out sum of terms. Are you able to see any pattern in these numbers? Whenever you see numbers are nearby, they are increasing, but they are not increasing in multiples. They are not becoming double, triple, 10 times or random increase. Go for differences always. If you see the value is 1, to make it 10, I must have an increment of 9. The value is 10, to make it 23, I must have an increment of 13. To achieve a value of 40, I must have an increment of 17. To achieve 61, I must have an increment of 21. Now, I'm getting an idea here. These differences are showing some sort of pattern. The differences form a AP. When differences form a AP, you see the common difference here is 4. Now, this is the actual sequence given to us. This is called level 1 difference, and this is called level 2 difference. So do you notice here the level 2 difference is a constant. When I reach level 2, the level 2 difference, the numbers have become same 4, 4, 4. So this kind of representation is called a quadratic sequence. This is called a quadratic sequence, and to derive results you'll have to work very hard. The general term looks like Tn is equal to an square plus bn plus c. But because you are attending one of my sessions and I've shown you general term and I'm not going to make you derive all of this. I'm going to give you some results. Again, derivation of these results we'll do sometime when you're attending a lecture of mine. See, A is the first coefficient, B is the second coefficient, C is the third coefficient. If you find out A, B, C, you will have all of your answers. This is called a quadratic sequence. The level 3 differences or the level 2 differences constant. So in all such cases, I want you to highlight this. The topmost value is always 2a. The derivation of this, again, we can do it in our live lectures. The first value of the difference is always 3a plus b. This is always 3a plus b, always. And the first value is always a plus b plus c. That is the universal pattern for a quadratic sequence. And no, you will not find this in the standard booklets. So here what I have is 2a is equal to 4. That provides me a as 2. Then I have 3a plus b is equal to 9. If I put 2 here, this becomes 6. 6 plus 3 is equal to 9. B is equal to 3. Now we have a plus b plus c is equal to 1. A is equal to 2, B is equal to 3, which is 5. 5 minus 4 is equal to 1. So what do I have? C is equal to minus 4. Now this pattern is universal. The derivation of it, I will do it for you in some class someday. From here you are supposed to derive the standard result. I have already done it for you. The left hand side is the trick. Excuse me. That makes my general term, the general term as 2n square plus 3n minus 4. Let us say I want to verify this. Is this result correct? Is this the actual general term? So do you see this happens to be the fourth term? This happens to be the fourth term. So I'll put 4 in this. So 2 into 4 square, 16. 3 into 4 and a minus 4. How much do I have? 32. 32 plus 12. 12 minus 4, 8. 32 plus 8, 40. So do you observe what have I achieved so far? I have created the general term. Once I create the general term, now I can go on and find out summation of terms. So I wanted to highlight the level 2 difference is constant. When the level 2 difference is constant, it's a quadratic sequence. In a quadratic sequence, the trick is there. 2a is the highest value, the topmost value. Then the lower value is 3a plus b. Then the lowest value is a plus b plus c. If you know this, you have found out your general term in 3 steps. The rest of it is derivation. Don't worry about that. I'll show that to you in a live lecture. Now I need to use this information to find addition. I am going to clean the screen. I am going to clean the whole screen. I found out the general term, that is equal to 2n square. 2n square plus 3n minus 4. That is 2n square plus 3n minus 4. That is general term. Now how do I find additions? Please understand, please learn this trick. The general term is Tn is equal to 2n square plus 3n minus 4. Now I want addition of 20 terms. So see, I'm going to put 1 here. So 1 square. I'm going to put 2 here. So 2 square. I'm going to put 3 here, 3 square. And I'm going to add all of them. That means I'm adding squares. So this is called sum, written as summation of n, which is basically 2 into n square. I'll put 1 here, I'll put 2 here, I will put 3 here, I will go up to 20 and I will add them. So I'm basically adding natural numbers. And then 4 is a constant, minus 4, minus 4, minus 4, n times. So 4n. So this is the method of finding summation. Summation means addition. Again, these are general terms. 2 into, what is this? Summation of squares. So n plus 1, 2n plus 1 divided by 6. That is the addition of squares. What is this? 3 into, what is this? Natural numbers. N into n plus 1 by 2. And this is basically minus 4. I need 20 terms summation. So I'll put 20 in all of them. This and this cancels out. I'll put 20. So 20 into 21. I will put 20 here. 41 upon 3. This will cancel 7 times. So 7 into this gives me 287 into 20. 0 here. 287 into 20. So I'll have 4 here. Carried over 1. 7 carried over 1. So I have 5740 plus. I'll just scroll this up. You can perform the calculation on your own now. Very simple calculation. I'll put 20 here. This will be 20 into 21 by 2. That will cancel as 10. So 30 into 21. That is 630. And if I put 20 here, that is minus 80. So here I feel I can get the answer by verifying the units position. The unit position here is 40 plus 30, 70, 70 minus 80. 70 minus 80. So I'll have to borrow. So my answer must end with a 90. My answer must end with a 90. So is this a difficult problem? No. Acha, some of the calculation is hidden behind me. Now you can see that calculation. Yeah, I just moved aside for you to see that calculation. Chalo. So you need to understand what kind of question is this. A quadratic series when the level 2 difference is constant. Now once you realize that, you must know the formula or the approach behind that. Once you know that, you find the general term and then apply summation. So this question has 3 to 4 layers. 3 to 4 layers that you must peel to be able to solve. And this is what CAT does. This is what CAT is testing in exam. You will not have single formula questions now. One step questions. Maybe you have practiced enough and you can solve it very fast. Give it a shot. Find the 20th term of this. Can you find the 20th term? I have tried to keep the session a little homogeneous. Similar kind of questions I've kept in the beginning, and then we'll go for the variety of problems. Here I have 1, here I have 1, 5, 11, 19, 29. I feel again some kind of increase is there. Here the increase is 4, the increase is 6, the increase is 8, and the increase is 10. And the increase is 2, 2, 2. This is the second level difference being constant. Now you know the value will be 2a. This value is always 2a. That gives me a is equal to 1. This value is always 3a plus b. Always. And a is equal to 1. That makes a is equal to 1. This is 3 itself. 3 plus 1 is equal to 4. That makes b is equal to 1 as well. Now what is the very first term? The very first term is a plus b plus c, which is basically 1 plus 1, which is 2. 2 minus 1 is equal to 1, which makes c is equal to minus 1. make sure you observe the sign change. C is equal to -1. So the general term that you will have, Tn, will be an square plus bn plus c, which will be n square plus n minus 1. Once you know general term, you can find out whatever value you want. You want to find out the 20th term. So what you do is you put 20 in the position of n. Put 20 here. That makes it 400. Put 20 here. That makes it 20 minus 1. That is 419. That turns out to be our answer. 420 minus 1. 490. People who are joining late, comment hi, hello, so I'll get to see who all are live. On WhatsApp, you are confirming. That's also fine with me. Good, good. Shallow. Going to the next problem. Let us try the next one. Give me a second. I'll just come out of this. Yeah. Hi, Gayatri. Chalo. Now, again, I have added 2 layers to the problem while framing it. You guys give it a try. I'll give you 2 minutes. I'll grab some water in between. You guys start. The sum of first n terms of an arithmetic progression y is given by 2n square plus 6n. A new sequence x is formed by taking every alternate term starting with the first term of sequence y. Find the sum of 21 terms of sequence x. So again, as I said, multiple layers have been added to this. First, you are not being told what the sequence is. You are being told the addition of sequences 2n square plus 6n. Then a new sequence is formed by taking every alternate term. In that sequence, you need to find out 21 terms. So forget the second part of the question. Let us focus on the first one. Here we have been told the sum of the sequence is this. If the sum is given and you put n is equal to 1, there is only one term, n is equal to 1. That is the first term. So when I put 1 in this, I get the value 8. For the sequence y, the first value is 8. Now when you put n is equal to 2 and it is the addition, now it is addition of 2 terms. So when you put 2 here, I will get the value of t1 plus t2. When I put 2 here, mental maths, 2 square 4, 4 into 2 8, 2 here 12, 8 plus 12 20. So first term is 8, addition of two terms is 20. So second term turns out to be 12. When I put n is equal to 3 here, n is equal to 3 here, if I put 3 here, this is 9 into 2, 18, and 3, 18, 18 plus 18, 36. The addition that I am getting here for 3 terms is 36. If the addition is 36, the first two terms add up to 20. So T3 must be 16. Now I am able to notice pattern. From here there is plus 4. From here there is plus 4. So it is a arithmetic progression with 8 being the first term and common difference being 4. So what will I have? I'll have terms here 8, 12, 16, 20, 24, 28, 32, and so on, so on. Out of these, I am selecting alternate terms. Please pay attention now to the second part of this. A new sequence X is formed by taking every alternate term with the first term of sequence Y, starting with first term of sequence Y. So I will take 8, I will reject this, I will take 16, I will reject this, I will take 25, I will reject this, and so on. Now what I have 21 terms and I want to add them. So this gives me an idea. When you select equally spaced terms, 8, 16, 24, luckily here it forms a table of 8. Luckily it forms a table of 8 for me. I need addition of 21 terms. I need addition of 21 terms. So can I take out 8 common and say it is 1 plus 2 plus 3 up to 21. There are 21 such terms. So my addition is 8 into this is natural terms n, which is 21, 21 into 22 upon 2. So your answer is ready now. Cancel it 11 times. So 8 into 11, 21. That is basically 21 into 88. And I have full faith in your calculation abilities that you'll find out the answer. 8 into 11 into 22. 8 into 21 into 22 upon 2. That is 8 into 21 into 11. Good. Good. Let us carry on. Let us try a few more questions. Oh, announcement. You guys have seen me announce this. People who are going to be random visitors. I'll be starting my new batch for offline course, Pune. 220 hours of learning, a very small batch size of 25. One-to-one mentoring is compulsory every month. You will be monitored and mentored through WhatsApp group, not Telegram. Telegrams are not that effective in that regard. And when CAT is over, I'll be giving you evaluations of SOPs and 3 mock PIs. You're going to get 4 massive books from me. The level of content in those books is much higher than what is being done in conventional classes. Conventional classes have been turned into sarkari naukari. ट्रेन लेट है क्या फर्क पड़ता है, बैंक डूब गया है क्या फर्क पड़ता है. So my lectures are not going to be conventional naukari, sarkari naukari. They are going to be grilling. So right now the offer price for you guys is 25k if you enroll in the month of April 2024. Moving on to the next slide, solving the question. Chalo. Something different involves a modulus, involves a square, involves a square root. So go on, give it a try. I'll wait for you guys. See, I'm one of those people who always push or always like to push his students to do more. Top 2% people will go to the top 10, top 20 colleges. So yes, are you the person who is putting in extra efforts as compared to the next guy? Smart work. Smart work plus hard work is the way forward, guys. Only smart work does not work. Chalo, try. First thing you notice, by giving you a general term, by giving you a general term, which is fairly weird. It is not a standard sequence. Some root over and modulus and square is going on. I'm asking you for 63rd term. So unless it is a fairly straightforward pattern, the question becomes unsolvable. And especially when it is a theta question on sequence and series, 63rd term, the pattern has to be very clear. Let me give it a try. When I take the, what does this mean? The next term of the sequence will be found by putting the previous term inside the root over. So if I want the second term, I will have to put here modulus the first term. If I want the third term, I will have to put here inside the square the second term, and so on, so on. So in first 4 or 5 steps, I do not see a pattern. The question is not solvable, at least by me or you in the exam for that matter. So I'll take this 7. 7 square is 49. 49 minus 16, 33. So what I have here is root over 33. Please be careful and observe. This is the second term. Second term is root over 33. When I put that root over 33 here, it becomes 33 minus 16, which is 17. That is root over 17. So if I want the fourth term, again in 4 or 5 steps, you don't see a pattern, skip the question. Na banega aapse. I am looking for modulus of third term square minus 16. So I'll take this and I'll put it here. Root over 17 square, 17. Minus 16, 1. So basically A4 is equal to 1. What will be A5? See, I will put 1 inside here. 1 minus 16 minus 15 modulus. So basically this is 15. What will be A6? I have not been able to see pattern so far. If I take that 15, if I put it here, root over 15 square, 15. 15 minus 16, 1. Now I see a pattern. Now I see a pattern. The fourth value is 1. Sixth value is 1. The seventh value will be root over 15. Eighth value will be again 1. Now I am playing in even odd sequences. A4 is same as A6 is going to be same as A8, A10. They are all going to be equal to 1 from here onwards. And A5, A7, A9, they are all going to be root over 15. So here I want A63. A63 will be equal to root over 15. A63 will be equal to root over 15. It's an odd position. 63 is an odd position. And every odd position now toggles with root 15. Even position toggles with 1. Good. Let us try a couple of more problems. Slightly higher level problem involves a modulus, involves a square, involves an inequality. Again, modulus will definitely have at least one modulus problem in CAT. Maybe in form of graph, maybe in form of area, maybe in form of an inequality. So what does the question say? How many integral values of x satisfy the following inequality? X must be integer. It must satisfy the inequality. The inequality must be true. So again, you need to understand how modulus works. A modulus opens with a plus sign and opens with a minus sign based upon what is inside. If the value inside is -4, so you multiply -1 with it to make it positive. If the value inside is 4, you keep it outside as it is. So what is inside decides the sign of the modulus in the equation. So here let me start solving this for you. This looks like to me as 9 to the power -1 bracket x plus 3 modulus upon 3 minus x modulus. As I had announced in the group as well, these are slightly higher level questions. These are workshops. And these are the questions you are supposed to be doing in classrooms. Once the theory part has been done, you are supposed to be solving such level questions because this is now the level of CAT. If I simply ask you to tell me what is the range of this, you and I are not doing justice with CAT preparation. This is what is being done in classrooms, and then most of the people don't end up clearing CAT. That generates repeat business for coaching classes, and the cycle goes on. So education has become a basically car service industry. Should not be happening. Theory jaldi jaldi karo, ek step aage badho theory se and solve such questions. So here what I want is, I need this to be more than, 9 square. So what we have here is minus of total x plus 3 mod upon 3 minus x mod more than 2. When you cancel a minus sign, the inequality will reverse. Now here I need to work with range of x. See, in the numerator, as long as x is on the right side, if x is on the right side, so the numerator remains positive. Look at the denominator. Mod of x. See, as long as x is more than 0, the modulus remains positive. So what I will do is, I will imagine a value of x here. X is more than 0. I am imagining that. I am assuming that. If x is more than 0, both these will work positive. X plus 3 will be positive upon 3 minus x is positive. I want it to be less than -2. I will rearrange it. I'll bring it on the left side. I will have to clean the screen. I have a finite space that I'm working with. Now if I solve this, this will go above. It will become -2. So x plus 3 plus 6 minus 2x upon 3 minus x. So that gives me 9 minus x upon 3 minus x below 0. Now this is called a wavy curve approach. What we do here is we draw a line, number line, 9 and 3, plus minus plus. How am I changing those signs? You will have to attend a live lecture to understand the wavy curve approach. So see, I wanted this ratio to be negative. This ratio will be negative. As long as x is here. What can be x? X can be 4, 5, 6, 7 and 8. So far I have got 5 values. Are these 5 values on the right side of x? Yes. I started the solution by assuming the right side of x. Now I will clean this to solve it further. That is the limit of the space I have. So I'll have to clean this. I've got 5 values. Now, what if I imagine x? To be between these numbers, between 0 and -3? I can directly put values as -2 and -1 and check. I can do that. I could do that. But here if you observe, I have moved on the left side of 0. So this will become negative. The numerator remains positive. And when this becomes negative, it becomes 3 plus x, which is equal to 1. Can 1 be less than minus 2? Can it be below minus 2? No. So there is no value of x here. There cannot be any value of x here. What if x is below minus 3? What if x is lower than minus 3? X is even below minus 3. That means the numerator becomes negative. That means the denominator here becomes negative. So what I have is minus 1. Can minus 1 be below minus 2? No. A smaller negative is more, guys. A smaller negative is more. This cannot be below. So there is no solution here either. There is no solution here either. So what solutions do we have? 5 values we have. Looks like today you guys are tired. Many of you have given up and moved on. So this is where we'll end the session. More people, longer session. Less people, shorter session. Basic equation, guys. So yeah, I'll see you guys in a day or two's time. Yes, I have conducted a survey with you guys. Many of you have asked me for 9:30 p.m. to 11 p.m. batch online. So let me speak with my app developer. Let me see where the app stands, and maybe I'll launch it soon. Yeah, I'll be sharing many more such videos, such concepts with you through my WhatsApp and Telegram group. A lot of those links you will find in the description. Good night, guys. People who survive from the start, that's very commendable. This is slightly higher level algebra, so you guys are expected to stay focused. Good night, guys. That's all from my side for today. We'll meet again live in a day or two. And this is the kind of level that is expected from you in CAT. If you're not solving this, CAT is out of scope. Bye-bye.